Right now, beneath the streets of Helsinki, there are people swimming laps in an Olympic-sized pool carved out of solid bedrock. About 20 meters below the surface, kids are bouncing on trampolines in underground playgrounds. Data centers are humming in caverns that could survive a nuclear strike. And most people walking above have absolutely no idea any of it exists. Helsinki has hollowed out nearly 10 million cubic meters of underground space. That's enough volume to bury every man, woman, and child in the city under a blanket of rock and still have room left over. Swimming pools, churches, sports halls, running tracks, even underground water features, all hidden beneath a perfectly normal-looking Nordic capital. But Helsinki isn't alone. Beneath Montreal, 500,000 people move through a 32-kilometer tunnel network every single day, shopping, eating, commuting, never once stepping outside. And over in Singapore, the government is doing something no country has ever attempted, legislating subterranean development rights for an entire underground city layer that doesn't even exist yet. These aren't bunkers. They're not emergency shelters gathering dust. These are functioning parallel cities operating right beneath the ones we see on postcards. And the question isn't whether underground cities are coming. They're already here. Okay, so this is why cities are tunneling beneath themselves in the first place. The answer is deceptively simple. They're running out of room. Imagine you're in Singapore. The entire country occupies just 734 square kilometers. That's smaller than New York City. Nearly 6 million people are packed onto that island, and the population is still growing. You can't build outward because there is no outward. You can reclaim land from the sea, and Singapore has done plenty of that, but there's a limit before you start annoying your neighbors. You can build upward, and they've done that too. The skyline proves it. But there's a third dimension that most cities have barely touched. Down. The logic is compelling. Underground space maintains a stable temperature year-round, shielded from tropical heat or Arctic cold. It's protected from extreme weather events that are becoming more frequent. And crucially, it frees up surface land for the things humans actually want to see: parks, housing, open sky. Singapore's Urban Redevelopment Authority has been mapping the country's subterranean potential using advanced 3D geological surveys. They're identifying rock types, water tables, fault lines, building a complete picture of what lies beneath every square meter of the island. The government has passed legislation granting state ownership of underground space below a certain depth, clearing the legal path for planned subterranean development. Their current strategy prioritizes utilities, rail lines, warehousing, and storage. The idea is to migrate the invisible infrastructure of a city, the pipes, cables, logistics networks, underground, liberating the surface for human life. It's not science fiction. It's urban planning with an extra axis. And when you look at what Helsinki and Montreal have already achieved, Singapore's ambitions start to look not just plausible, but inevitable. Now, Helsinki's underground story begins where so many extraordinary engineering feats do, with fear. During the Cold War, Finland shared a roughly 1,340-kilometer border with the Soviet Union. The threat of nuclear conflict wasn't theoretical, it was geographical. The Finnish government mandated that buildings above a certain size had to include shelters, and Helsinki's granite bedrock made tunneling not just possible, but practical. What started as civil defense evolved into something far more remarkable. Today, Helsinki contains close to 500 separate underground facilities connected by more than 300 kilometers of tunnels. The city has roughly 5,500 shelters with capacity for nearly 1 million people. Here's the thing, Helsinki's population is only about 700,000. They've built enough shelter space to protect every single resident and still accommodate 300,000 visitors. But the genius isn't in the shelters themselves. It's in what they do the other 99.9% of the time. Take the Itäkeskus swimming hall, opened in 1993. It's carved directly into bedrock beneath the eastern suburbs. Inside, you'll find multiple pools, saunas, gyms, and sports halls, all blasted out of solid finished granite. About 375,000 people visit every year. Families bring their kids on weekends. Office workers pop in for a lunchtime swim. And within 72 hours, the entire facility can convert into an emergency shelter. The pools drain. The changing rooms become dormitories. The ventilation system switches to filtered air. A place of leisure becomes a fortress. Then when the crisis passes, the water goes back in and everyone returns to doing backstrokes like nothing happened. This dual-use philosophy runs through Helsinki's entire underground network. The Merihaka shelter includes a children's playground, basketball courts and gym space, all carved deep into rock. Retirees play ping pong in the Maunula Sports Hall, dozens of meters below street level. The Tempelia Church, one of Helsinki's most visited landmarks, is built directly into a rocky outcrop with its interior excavated from stone. And then there are the data centers. Helsinki's underground caverns offer naturally cool temperatures, reducing the enormous energy costs of keeping servers from overheating. The rock provides physical security that no above-ground facility can match. Several major data operations have moved into these subterranean vaults, turning Cold War-era excavations into 21st century digital infrastructure. All of this is coordinated through Helsinki's Underground Master Plan, a unique 3D planning framework that maps subterranean space alongside surface development. It ensures that what's built below doesn't conflict with what's built above and that future tunneling doesn't compromise existing underground structures. The cultural achievement here is remarkable too. These aren't grim concrete bunkers. Finnish architects have invested in lighting, ventilation, and spatial design to make underground spaces genuinely welcoming. Visitors often remark that they forget they're underground at all. Now, from Helsinki's bedrock to Montreal's brutal winters, let's cross the Atlantic to a city that solved a very different problem by going underground. Montreal gets hammered by winter. Temperatures routinely plunge to minus 25 degrees Celsius, with wind chill dragging the real feel far lower. Snow blankets the city for months. And for decades, that meant the downtown core essentially shut down every winter. Pedestrians vanished. Retail suffered. The economic heart of the city went into hibernation. The solution began in 1962 with a simple idea: connect buildings underground so people could move between them without stepping outside. What started as a few tunnels between a metro station and a shopping center grew into something the Guinness World Records now recognizes as the largest underground shopping complex on the planet. Montreal's Réseau, formerly branded with that name in 2004 from the French word for network, connects over 60 major buildings through approximately 32 kilometers of tunnels spanning 12 square kilometers of downtown. And the numbers from there are staggering. The network links roughly 2,000 shops, 1,200 offices, 200 restaurants, 40 cinemas, 40 banks, 7 major hotels, 4 universities, concert halls, exhibition centers, and even a cathedral. It integrates with 10 metro stations and 2 commuter train terminals. There are around 120 exterior access points where you can descend from the surface and enter this parallel world. Around 500,000 people use the Réseau every single day. Think about that. 500,000 daily users moving through a network that most international visitors don't even know exists. You could arrive at Montreal's Central Railway Station, check into your hotel, eat dinner, catch a concert, go shopping, and attend a hockey game at the Bell Center, all without once feeling the sting of a Canadian winter. But the Réseau isn't without its problems. Navigation is notoriously confusing. Signage varies wildly between sections because different buildings are managed by different private owners. One Reddit user described it as feeling like a video game city, maze-like passages that seem to lead everywhere and nowhere simultaneously. Tourists get lost. Even some locals admit to taking wrong turns in sections they don't frequent. There are also questions about maintenance and modernization. Some sections feel dated, with fluorescent lighting and aging tile that hasn't been refreshed since the 1980s. Critics argue that the network has been over-promoted as a tourist attraction when parts of it function more like utilitarian access corridors than the glamorous underground city the branding suggests. And yet, the fundamental achievement is undeniable. Montreal proved that underground networks could become integral to a city's daily economic and social life. Not an emergency backup, but the primary artery through which hundreds of thousands of people choose to move. When seemingly every square meter of surface land costs millions, it's easy to understand why a country like Singapore would look beneath its feet for answers. But Singapore's approach is fundamentally different from Helsinki's or Montreal's. Those cities built underground reactively, Helsinki in response to Cold War threats, Montreal in response to winter. Singapore is doing something proactive. It's creating the legal and technical framework for underground development before most of the construction even begins. In 2019, the Singapore government amended its law to grant state ownership of underground space below a specified depth, typically 30 meters or deeper. This is extraordinary. It means the government can plan, allocate, and develop subterranean space without having to negotiate with every surface landowner above. The Urban Redevelopment Authority has been building comprehensive 3D maps of Singapore's underground geology, cataloging rock formations, soil conditions, water tables, and existing buried infrastructure. This digital twin of the subsurface allows planners to identify which areas are suitable for excavation and which should be avoided. The current priorities are practical rather than glamorous. Singapore wants to move industrial logistics, utility networks, and storage facilities underground, freeing surface land for housing and green space. The Jurong Rock Caverns, completed in 2014, already store liquid hydrocarbons in caverns excavated 130 meters below ground, the first such facility in Southeast Asia. Looking ahead, proposals include underground science cities, freight distribution networks, and even reservoirs. The International Tunneling and Underground Space Association has pointed to Singapore as a model for how nations can systematically plan subterranean development rather than stumbling into it. The ambition is nothing less than creating an entirely new layer to the city, not replacing what's above, but complementing it, a service layer that handles the essential but unglamorous infrastructure every modern city needs, invisible to the people living their lives on the surface. Now, this all sounds transformative, but underground development carries risks that don't always make the brochure. Cost is the most obvious. Tunneling through rock is enormously expensive. Helsinki's underground facilities have been built over decades of sustained public investment. Montreal's Réseau relies on a fragmented ownership model where private developers maintain their own sections, leading to inconsistent quality and upkeep. Singapore's subterranean ambitions require not just engineering budgets, but entirely new legal frameworks and geological surveys that cost hundreds of millions before a single tunnel boring machine starts turning. There are accessibility concerns too. Underground spaces can be disorienting and difficult to navigate for people with disabilities, the elderly, or anyone unfamiliar with the layout. Emergency evacuation from deep underground facilities presents genuine safety challenges that surface buildings don't face. And there's a philosophical tension worth acknowledging. When cities invest billions in underground infrastructure, there's a risk that surface-level urban problems, affordable housing, green space, public transit, receive less attention. Building down doesn't automatically mean building better. Environmental questions persist as well. Excavation generates enormous volumes of waste rock and soil. Ventilation systems consume significant energy, and the carbon footprint of tunneling operations is substantial even if the finished spaces offer long-term efficiency gains. Despite these challenges, the trajectory is clear. Cities around the world are increasingly looking underground, and not just the three we've examined. Beijing has built extensive underground commercial districts. Seoul has experimented with subterranean urban farming beneath its metro system. Paris is exploring how to repurpose historical underground spaces for modern urban functions. Each city brings its own geology, its own climate pressures, its own political context, but they're all arriving at the same conclusion. The surface alone cannot sustain the density of modern urban life. Helsinki's underground master plan represents perhaps the most sophisticated approach, treating the subsurface as a three-dimensional extension of the city that must be planned with the same rigor as what's above. Montreal's réseau demonstrates that underground networks can become so woven into daily life that 500,000 people use them without thinking twice. And Singapore's legislative framework shows how governments can get ahead of the curve, creating the rules before the rush begins. What connects all three is a recognition that the most transformative infrastructure isn't always the most visible. The Golden State Bridge is iconic. The Burj Khalifa dominates a skyline, but the spaces beneath Helsinki, Montreal, and Singapore serve millions of people every day without demanding a single glance upward. Thanks for watching Hard Hat Industries, your source for the massive engineering and heavy iron shaping our world. If you appreciate the scale and technical complexity of these builds, hit like, subscribe, and turn on notifications so you never miss a breakthrough.